Hello everyone. Today we discuss about different machine cycle in a 8085 for different instructions. So first of all, using machine cycle we can understand the different working function of 8085 for different instruction. So there are basically three types of instructions. Number one byte instruction. In a 1 byte instruction there is only one operation are required, known as opcode phase, and number two is number two is 2 byte instruction. In this type of instruction there are two operations are performed. One is opcode phase and second is memory read operation. And number third is 3 byte instruction, where the operation is opcode phase plus memory read, and some instructions are required extra machine cycle, which is known as memory read or memory write operation. Okay, so now we discuss about the different types of instructions and then machine cycle. So first of all, for 1 byte instruction, for example, the instruction is say move A B. So it is only a 1 byte instruction. So here only required only one opcode. This opcode, only one opcode for this instruction to execute this instruction. So this instruction is only required the opcode phase operation. So first of all, it is noted that for opcode phase operation in 8085 there are 4 clock cycles are required. That means 4 T states are required. For memory read and memory write operation required 3 T states of or 3 clock signals are required. In some special instruction for opcode phase they are required 6 T states or 6 clock signals are required. So first of all, we represent the machine cycle for 1 byte instruction, that means move A comma B. Okay, for this instruction we represent the machine cycle. So first of all, draw the 4 T states. Draw the 4 T states. So now this is the 4 T states. This is the first machine cycle, which is known as opcode phase. This is opcode phase, or also known as machine cycle 1. Now this is a T1 clock, this is a T2 clock, this is a T3 clock, and this is a T4 clock. So this is represented by the clock signal. This is a high state and this is a low state. Another clock high state and low state. Another clock high state and low state. So this is the clock signal. Let us assume these instructions are written in 800 hex memory location. So now these 800 hex location, the lower order address and data bus, the address contains 00, and higher order address content 80. Okay, so from A15 to A8 these address bus are operation in a 3 states, and content is 80 hex, and there is extra signal required in 8085 known as ALE. When ALE equals to high, then these demultiplex address and data bus are working as a address bus. Okay, so what is the address? 00 hex. And after this, when ALE becomes 0, then these address and data bus are working as a data bus. So here we place the opcode, and after this will be terminated. So this is a clock signal. This is a higher address bus which is contained in a 3 states. ALE becomes high, and when ALE equal to high, then this demultiplex address and data bus are used as address bus, and when this becomes 0, it is used as a data bus, and in this data bus it contains the opcode of move a, b. This opcode is coming from memory to microprocessor to operate what type of instruction it is. Now next pin is IO/M bar. This IO/M bar pin is becomes 0 because this is a memory related operation, and here 2 pin S1 equal to 0 and S0 equal to 0, it stands that this is sorry S1 equal to 1 and S0 equal to 0. This stands for this is the opcode phase operation. Now one extra signal required, read bar. This is a memory read operation, and both IO/M bar and read bar together with this signal, we generate one extra signal which is connected to the memory. It's called memory read bar. So memory read bar is low here for memory read operation because this opcode stored in a 800 hex memory location. Okay, so from 800 hex location we read this opcode and send to the processor, where it is sending IR, instruction register, and after this instruction register, this opcode goes to the instruction decoder and timing cycle, and there it is recognize which type of instruction it is. It is data transfer type or arithmetic type or logical type. So that's why microprocessor recognize the instruction type and gets its proper operation. So now this is the opcode phase operation and required 4 T states, and each T states and every T states or clock time period we show the different types of operation. Okay, now next we show or represent the machine cycle for 2 byte instruction. For example, the 2 byte instruction is MVIB, 07. So this instruction written in 8000 hex and 8001 hex, say, and the opcode of MVIB is getting from the instruction chart. This is the instruction set. I'm corrected from this internet. Don't remember this opcode. When you execute any instruction or written the instruction in your notebook, please collect or please search this opcode with a hexadecimal code from this chart. So I use here move MVIB. So search here what is the instruction of MVIB. MVI means where it is place the MVI instruction. So this is the MVIB instruction. Okay, this D8 means data 8 bit. What is the opcode of MVIB or hex code? That means 06. Okay, and this D8 is user defined as your choice. So here we written the code 06 and this is 07. Okay, so now in the 8000 the content is 06 and the 8001 the content is 07. Okay, now we draw the machine cycle. So first of all, the first operation is opcode fetch. Okay, so in the opcode fetch machine cycle there are 4 T states are required, and in the memory read there there are 3 T states are required. So this is our first machine cycle. This is M1, which is known as opcode fetch, and this is M2, which is also known as memory read operation. So this is our T states: T1, T2, T3, T4. This is again starting from T1, T2 and T3. Now this is the clock signal, which is present as a high and low states. Okay, now this is higher address bus. In the higher address bus, the content is 80 and it goes to the up to 3 T states. So here the first address is 80 hex, this is a higher address, and this is ALE. This ALE is high here and again low and again higher and then low. So these demultiplex address and data bus are used as a first address bus to get the perfect address where we store the opcode. So what is opcode? In 800X, the opcode is 06. That means this is the instruction of the hex code of MBIB. So next, what is the content here? Here the content is 80 again, and what is the content here? We have 01, and after getting low of ALE signal, we get 07 data from the memory. What is a IO/M bar? IO/M bar is low all over the clock time period. Okay, and here S1 equal to 1, S0 equal to 1. Here S1 equal to 1, S0 equal to 0. These status signals shows that this 1 means opcode phase and this 10 means memory read operation. Okay, and last one, memory read signal, which is go 1 here to coming out this opcode from the memory, and here the memory read body is low to coming out the 8-bit data from this memory. So here we note that, so in the first machine cycle it select the 800 hex memory location, and from this 8000, when this memory read bar equal to 0, then it's read out from this memory and goes to the instruction register of 8085. Okay, because this is opcode fetch operation. And after the second machine cycle, the memory in the address bar content, in the address bus content 8001 hex memory location, and the content is data. This is a data, not a opcode. So that's why this is 1 and this is 0, because this is not opcode fetch. This is a memory read cycle only. That is, the data is read from this location 8001 location. Okay, and content in a B register, so it goes to the register B, because we return the instruction MVIB equal to 07. So before getting this data, we execute in this opcode fetch operation, and in this opcode fetch operation, microprocessor understand that our next 8-bit data is goes to the MVIB. That means in the register B. How it is recognized that it is goes in the register B? Because this 06 understand in the format, and this format is recognized by instruction decoder and timing cycle. So that's why microprocessor understand that this is a register B, and for different types of register this code is changes, this 06 is changes. So from this chart we look that, so from this chart if we look that there are lots of MVI instruction, MVI B 06, MVI C 0E, MVI D 16, So for different MVI operation, there are basically 1 2 3 4 5 6 7 8 registers are exist in 8085. MVI M is a HL pointer register. In the later video we will discuss about that. Then what is it? It is when HL pair is loaded any 16-bit value, then 16-bit value is represent in a memory register, is also known as memory register. So there are different types of instruction, and by different of these instructions, microprocessor understand that where the data will be go, either B, either C, either D, or I, E, or A, anyone. Okay. So in the next video will be discussed thoroughly about 3-byte instruction and its machine cycle.